Hello everyone, and thank you for joining us today for our HashiCorp webinar, where today we'll be talking about how to unlock the cloud operating model, and specifically how that applies to organizations in the Nordics. My name is Connor Beechnor, Senior Field Marketing Manager here at HashiCorp, and today I'm joined by our Global Field CTO, Brent Holden, who'll be your presenter today. In terms of the agenda, we'll start off by showing some trends that we're seeing in the migration to multi-cloud and that transition to DevOps. We'll then look into some of the challenges that Nordic organizations are facing and how to solve that with some real world use cases. Then to wrap up, we'll have a live Q&A session at the end. So please submit any of your questions via the Q&A box and we'll answer those afterwards. Please note that this webinar is being recorded and we'll send everyone a copy via email after it's been processed, usually within a day or two. So with that, over to you, Brent.
Thank you, Connor. I appreciate the intro. Welcome, everybody, and thank you for taking time out of your day to spend with us. My name is Brent Holden. I'm the Global Field CTO here at HashiCorp. I guess, simply put, that means I'm the traveling CTO. It means I have to partner with our corporate CTO, Armand and Mitchell, and represent our technology teams into the field, which means a lot of what I talk about are how companies are not just consuming our technology, but how are they structuring their processes and their organization around what they're doing with us. And that's a lot about what we're going to talk to today. So let's sort of roll forward. We have a lot of content. I want to make sure we don't miss any. The thing is that there's going to be some very obvious transitions that are going on. So please just bear with me, and we'll get to the less obvious stuff, and then we'll get to the things that are not so obvious. So I guess to start, you have seen in the market, almost guaranteed, the reason you're on this call is because you had a traditional data center that had dedicated infrastructure. It was a literal four-walled place you could drive to. You had folks that worked there that racked and stacked equipment. And that was the way we did things for a very long time. What we're seeing now is we're seeing the modern data center, where now you're sort of changing what that traditional data center looked like into what most companies call private cloud, which is primarily capabilities based, and you're augmenting that with public cloud. And what that means is for some companies, they choose to go, with AWS, Azure, Google for myriad reasons. I would say, like, based on my interactions with the customers, most companies are starting to see the differentiation within the public cloud providers. And so it is their choice to go multi-cloud. Now, we believe that you are going to be a multi-cloud company. Part of the reasoning is because you may just see that, maybe my Linux workloads live on AWS and maybe my Windows and .NET workloads live on Azure. That may be one reason. Maybe that data science workloads live on Google. And so you may be intentionally selecting different providers for different workloads. And then there's the accidental multi-cloud. You as a company may have chosen to go all in with AWS. You acquire another company that is all in with Microsoft Azure. Now, congratulations, you are a multi-cloud company. So we believe that's where most companies are going to go. What we see driving most of public cloud consumption is what we call systems of engagement. So within your private data center, those are a lot of applications that aren't going to move anytime soon. Think of things like SAP, Oracle E-Business, even PeopleSoft. Those are things that just, they have whole application teams. They need a major re-architecture effort, and there's a lot of business risk associated. The new types of systems that are driving public cloud consumption are what we call systems of engagement, which just mean, it's those front office applications that companies are delivering to improve the customer experience. Okay, so let's kind of walk through each of the different layers where HashiCorp is relevant. We don't solve every problem in public cloud. We do solve quite a few of them. Some of them you will not be aware of. I think for the first layer, most folks are familiar with HashiCorp and Terraform. That is the way that we believe people should provision infrastructure. And previously to that, you would have this dedicated room or dedicated facility. You rack and stack equipment, and those would be primarily some bare metal, primarily on VMware. Otherwise, I think most companies try to get a majority virtualized. And what we see is the new way of doing that is basically doing it on demand. As you're engaging with public cloud, well, public cloud has seemingly limitless capacity. And so it allows you to grab capacity on demand. And we're also seeing more types of services being deployed. So it's no longer just virtual machines, but also container-based applications and serverless-based applications. I think the security layer is the next up. It's what most of our customers struggle with the most. It's because there's this sort of change in model. Now, I'll talk to it for a minute, and I have to kind of move on. The basis of it being a high trust network on an on-premise and dedicated infrastructure is that in the previous world, the data center being this physical place had a very clear point of demarcation. So where your network ended and your provider's network began, you'd put your firewall, your web application filters, your SIM, sort of all of your network middleware. And it sort of made one guarantee. The guarantee was everything outside is bad, everything inside is good. And so there was a sort of this model of high trust, an implicit trust for your internal network. Now, I don't necessarily believe that was always the case, but that was the model we used to explain it. The new world, this public cloud world, things are logically created. So you're not literally creating a physical data center every time you deploy. It's a logical space. And because of that, if you want something to exist outside your firewall, well, in the previous world, you had to call your network operations team, ask them to unplug it, wherever it was, and plug it around the firewall. And they would just say no, and then hang up on you. In the new world, you can tell Amazon, give this instance a public IP, and that's it. That's all it takes. Or you can say, put this S3 bucket as public, and Amazon will happily serve it up to you. So the new world means that the model shifts. The new world means that there is inherently sort of this change in the level of trust. Now, if you're an optimist, it could be 99%. If you're a pessimist, it could be 50%. Whatever that number is for you, it's not 100%. And because of that, we have to make a whole different set of assumptions. Mostly it's that your attacker is on network. And if your attacker is on network, that means we have to start embracing things like defense in depth and using stronger identities to provide service security. So that's what we mean by low trust and high trust. Sort of going along with that, when we talk about networking applications forever, even today, we're creating, host-based rules, which just mean, generally they're firewall rules that are IP1 can contact IP2. And that works great when IP1 and IP2 never change. However, in the new world, you'll have things like Kubernetes pods spinning up and down. Nobody wants to put firewalls within their Kubernetes cluster. I think it's already a hard enough job to run a Kubernetes cluster. And so we need to switch to being service-based, having service-based policies and being service aware. And sort of the last layer up, we used to, when I was an operator, roughly a century ago, people in the development group used to throw a tarball over to me. I would provision, a server, be it bare metal or virtual, and deploy their tarball with their instructions and, talk to them a couple weeks later. And now the new model is that we're scheduling applications that are not dedicated to one instance or scheduled across a fleet of instances. We have to kind of assume that there's going to be some type of failure underneath. That could be an instance that's spontaneously rebooted. That could be, a network that fails or goes away. It could be there's myriad reasons why we need to treat it as a fleet for reliability purposes. Okay, let's talk about some of the less obvious transitions that are going on. So I think we talked about some of the technology transitions that are going on. The least obvious transition is the process transition. Now, for your traditional data center, almost every company I know uses some form of ticket-driven process based in ITIL, using an ITSM. There's nothing inherently wrong with that. It's the way that we've always done things. And what we see with companies adopting public cloud, the ones who try and apply their old ITIL processes are the ones who are really falling behind. It's just really hard to keep up with the rapid change of a cloud infrastructure using older processes. Newer companies are trying something different. what they want to do is extract the kind of agility they can get from public cloud. And by doing that, moving more towards an API-driven self-service type environment. Some companies will call that DevOps. Some companies will call that CI/CD. I think really it is that key phrase, API-driven self-service. That's where most companies want to get to, and that is where HashiCorp, I think, has its biggest impact. So specific to the Nordics, this is a survey that was taken last October, so this is pre-COVID-19. However, it does illustrate some of the top infrastructure challenges that are facing some of our practitioners. And generally speaking, automation orchestration, as well as multi-cloud management, those are easily the top two. Almost every company I've spoken to has been grappling with those. And a lot of it's because they're trying to use automation orchestration as a way to just improve the amount of things people are capable of doing, as well as reducing the amount of errors that are made when they're completing those tasks. Okay, let's sort of step through the challenge, so to speak. And the challenge is not necessarily just technology related. I think for most of the customers I speak to, well, they're not made of technology, they're made of people. So people are the things that drive the organization and its success. And so we measure those in terms of what skills they carry, what is the culture, how do we communicate with each other, and then what KPIs do we carry for performance. Now, the way that we scale those teams is via process. If you don't need to scale something, don't worry about process, but generally if you're worried about scaling and inter-team communication, that's where process really comes into play. And really you build processes around KPIs. So it makes it easier and better for you to be able to deliver things that matter to your performance. Now, the last thing we should think about, but it's usually the first thing we think about, are the tools. For most technologists like myself, sort of gravitate towards what tools are out there, what can they do, what are they capable of, and they tend to get very philosophy specific, but really they're not really designed to, you don't use a tool just to use a tool, you use it because it helps you do something. And really the goal of a tool is to help enable and underpin process. That's the whole point of it. And so that's the way we look at most organizations and the shift that's playing out. Now, for some companies, they want to invest in what we call the unicorn. So somebody who knows development, operation, networking, and security. A couple of things about this person. This person does not exist. If they did exist, they would be heinously expensive, probably not worth paying for. And even if you found them and you could pay for them, you can't scale them. They don't scale to an entire organization. So generally, it's not a good use of time to go look for this person. And you need to start thinking about how do we scale the organization in a different way. And so let's look at the teams that we do have. Almost every company has development teams, operations, networking, security. It's very common teams. And we have to start thinking about how are we shifting their skill sets, right? Because people are the things that drive the organization. And for developers, it's about making them more autonomous. For SRE, where its operations is slowly morphing into, it's more about developer enablement. So how do we allow them to consume the platforms that we built for them? For the networking folks, it's about allowing them to become more application aware and create service-oriented policies rather than just strictly IP-based, which is going to be very problematic in this very dynamic world we're entering. And sort of fits right in with our security team. Security is no longer the checkbox at the end of the process. Every company I speak to, and I mean every company, they're implementing security as a step at every single link in the chain for how they deploy applications. It's no longer just a checkbox at the end. It's something they have to consider the entire time. And security is now more identity-based and has to be integrated with our applications as part of the process in which we build them. Okay, so we've been talking a lot about ITIL processes. Let's take a closer look at what this means. Now, for almost every company I speak to, what they've done is they've created these different silos of technology. So you have a compute team that might be the VMware team, and they own the VMware vendor relationship, and they also own the VMware technology stack. If you want their resource, you have to file a ticket to get it. Same thing goes with the firewall team, whether you've invested in Palo Alto or Cisco. Same thing goes with the load balancer team if you invest in something like F5. And so from the developer's perspective, the developer, to gain access to resources, they have to file a ticket, which, for most compute teams, that could be 2 weeks. So they get their ticket. Compute team says, absolutely, we'll get that done for you. We'll see you in a couple of weeks. Your next hop is to the firewall team. Firewall team says, absolutely, now that we have your IP address, we'll create some rules for you. We will see you in about 12 weeks. And then the load balancer team, they're usually the last ones in the step. Hey, we want to activate our service. And they'll say, yes, absolutely. We'll see you in about 8 weeks. So even in this super simplistic model with only 3 different groups, you're already talking about 22 weeks of effort. And that is what we call the time to value. That's really the thing the developer cares about. They don't really care about interacting with these teams. They care about how long does it take me to deploy my thing. And even if you have, as an organization, optimized some of these things, I know a lot of organizations have optimized the compute chain to take only 5 minutes. Well, okay, so that means the rest of your processes are 20 weeks and 5 minutes. So you really have to start thinking about what is that overall time to value? How do we deliver against that? Now, in the case of one major US telco, they're very large. You have definitely heard of them, even though they're on the other continent. We started talking to them roughly, it was about a year ago now, about what did their process look like to deploy applications and how many technology owners did they have. And what we found is that their application deployment process was 72 steps, and it took roughly 10 months. Now, I think that's a clear sort of problem that nobody wakes up in the morning thinking they're going to create a 72-step process. But that's how we ended up here, because that's how we always did things. We always did things by taking a technology, putting a ticket queue in front of it, and adding it to our process. And then over time, it just grows to 72 steps. So their 10 plus time was their time to value. That is the key metric that they were trying to improve. So some of the things that we've talked through today were, what are the existing principles and how do they apply? For most technologists, they own a specific technology, they own the technical domain, and they are the gatekeepers. Right? You will file a ticket against them. They will resolve your ticket and give you access to resources. They do that for sometimes capacity reasons. They do that for process reasons. And that's just it's just how we've always done things. And the changes that we see necessary are that we need to think about what is the process domain. How are people consuming these resources? And that key metric of time to value, how do we reduce that number to something that instead of 22 weeks could be 5 minutes? The last thing is thinking about self-service driven enablement, having self-service be sort of center to what we want to achieve, assuming that we don't want these centralized teams chugging through tickets anymore. And so the new DevOps processes become, instead of having like the compute team, the people that manage the interface to the developers are the provisioning team. Now, the provisioning team is, in the United States, we call this a T-shaped team. That's effectively a team that's thinking about what is the workflow, right? So you want to make it so that it's a single API call to get your infrastructure across all these different technologies, not just the compute, and then you have to hop with a ticket queue every single time. So they have a provisioning team that sort of sits across all that. That is the workflow that we talk about. The same thing goes with deployments, thinking about what is the API developers want to use to deploy their product. Same thing goes for security. How do we get database secrets? How do we get certificates? Making that an automated version of itself. And so those teams have to start maintaining new systems to be able to do that. If you're going to, if the mission is to go towards API-driven self-service, well, then you have to start thinking about how do we offer an API as a service internally that people can consume. Now, with functions like with platforms like Amazon or Google or Azure, they provide this naturally within the platform. However, if you want to start consuming that with on-prem, or if you want a multi-cloud approach, because we believe you're going to be multi-cloud, you have to start thinking about these systems in terms of how do I provide a system that can integrate with all these different things. Okay, so there is a multi-layered impact. I think at first, the people it's going to hit the most are the people. And it's people have to get more automation oriented. They have to start thinking about autonomy and responsibility, and they have to think about, how do my skills need to change? What do I need to do differently? For processes, it's more about enabling self-service and really thinking through, what is that workflow? I think the one differentiator that HashiCorp has is that we are a technology company, but more importantly, we are a workflow company. So we try and think through, how are people going to use our software, and what is the workflow going to look like? And the last is really around like those systems being API driven, as well as enabling cross-team coordination. How do we make it so that the tools are the things that enable the process, not thinking about the other way around in terms of tools first? Okay, so for the Nordics specifically, this came from an IDC survey, also in October 2019. We talked about the impact of that automation. What does that mean in terms of just business outcomes and or impact? And for the Nordics, we found that reduced costs are actually the number one driver for automation, not necessarily just in terms of people, but because you're not necessarily going to reduce the size of your teams, but it's more about doing more with the people you have on staff. That's what I mean by reduced costs. I mentioned earlier was improvement in quality and accuracy. I also mentioned that there was we call it customer satisfaction, but it's about improving the outcomes of the things we're doing. You're making it highly repeatable. You're reducing costs. You're, I guess, improving the amount of time that you have available to free yourself up to do other things. Okay, so let's talk through the things that, the buzzword terms that we talked through. I tried to hit them all in this section, and then we'll move on to sort of what the things to do going forward. Okay, so infrastructure as code is clearly a buzzword term in the industry. This is a space that HashiCorp helped define, and we defined it by having like this change from, instead of you as a developer looking for infrastructure via ticket, and that being your interface to the operations team, the operations team would then take your whatever you needed created and just point and click in the UI. I think some companies call this click ops, is really how that sort of breaks down. The goal is to really shift that, instead of being this ticket-driven process, into being an API-driven process. And the API request is effectively this block of infrastructure as code. Now, it helps us define what needs to be built. And the infrastructure team is really, what they're doing is maintaining all the integrations around, how do these things work, and what are the different technologies that you could possibly deploy into. So the developers are, given sort of the option to write infrastructure as code. There's also a UI experience. So for some development groups, they may not necessarily know or care about what infrastructure gets deployed when they deploy their apps. And so the goal would be to offer them a service catalog type experience where, through a tool like ServiceNow that they're familiar with, they can just click what sort of thing they need. And maybe that's, Java on AWS, .NET on Azure, and we can just go make the thing happen for them. But the infrastructure as code kind of backplane backs that up. It makes things highly repeatable for the operations team. The infrastructure as code really serves as kind of a blueprint in that case for how infrastructure gets created. And so really the points of value for infrastructure as code are really around splitting the execution from the definition. I know that sounds kind of strange. When we used to request things via ticket, that person on the other end usually had this run book, sort of a process worksheet, and they would sort of point and click in the interface and say, okay, well, this person needs an 8 gig virtual machine. This is how I go create it in the interface. And what we're doing is we're sort of splitting out the request from how it gets done. And so now we can sort of define not just within one type of infrastructure, but we can say, well, certain things live on VMware, certain things live on, let's say Kubernetes that we have to integrate with, certain things live with Datadog, certain things live, with, let's say, the F5 or Palo Alto. There's a myriad of other providers that we have. And that's sort of the point, is you're sort of defining the infrastructure and then you're handing it over to the system, and the system is executing it. That way you have a clear record of what got done and what didn't. And because of that, it allows us to use infrastructure as code as a blueprint. Right? It's consistent and it creates documentation as it goes, so you know exactly what was created and what was not. Okay, so let's look at identity-based security. So I think this is one of the hardest ones. I talked about security being a big challenge for most of our customers. In the traditional world, we had, web servers needed to connect to databases. It's everybody's problem. And we always slapped a firewall in between because we want to protect our data access. And so the firewall's job has one job. It allows a web server to connect to the database. That's it. And that's the only person that's allowed, the only system. Now, this works great until you have web servers that dynamically scale for load. And all of a sudden you have to worry about all these different IP rules. So, these different web servers get different IP addresses. And if you're wondering how we ended up with, some firewalls have like, 60 million rules in them, nobody can tell you what 98% of them do. This is why, is because we keep track of the IP addresses, but we're really losing the intent. The intent is, I have a web server service that needs to contact a database service, and I want access granted between the two of them, and that's it. But what we end up doing is tracking the IP address for everything. And in that dynamic world where things change frequently, that becomes very problematic. So the goal would be to have, in this case, it's a firewall looking at a registry for dynamic access rules. So it allows itself to update as web servers come in and register to a registry. The firewall can look at that registry and say, okay, well, you can manage the intent, and the intent is web servers can access database servers. How it gets implemented is firewall rules that the firewall worries about. And so you're still managing the higher level, what we call the intent of the transaction. You're no longer managing the IP address rules. And so having that identity-based security is really important when you have a dynamic environment. And so the thing is to be scale independent. You don't want to be managing, a multiplication problem of firewall rules. You want to manage one intent and have firewall rules be a technical detail underneath, right? And so using that, we can then start implementing what we call zero trust networking. So it's really that concept of defense in depth, leveraging the built-in certificates that these things use to identify each other, and use that as a basis for how they connect to each other. And so how most companies get started sort of on this journey is they start automating those firewall rules and or load balancer rules. That's actually where most companies start, is they put in the registry, right? That gives you an active view of what's out there. The second level type of problem is they start automating the things they already have. The third level problem is they start removing things they have. So in terms of using service mesh does not necessarily, it doesn't necessarily change the problems you're solving. The problems that you solve for application deployments are these things authorized to talk to each other? And are they available? Is there a service I can talk to? Right. So those are solved respectively by firewalls and load balancers. And service mesh sort of pushes those concepts out to the edge, where every application is aware where all the other applications are. That's what we call discovery. And then you're setting rules with each application that say, based on this identity, this other app is able to talk to it or it's not. And that's how we implement security. And all that is backed by mutual TLS communication between all different apps. Okay, so we're moving on to how developers deploy things. Most developers, they gravitate towards containers. They make it really easy to deploy applications, really easy to make it repeatable, sort of like an assembly line style. So That's really the goal around containers. It's not a world-beating technology. It's just a technology, sort of it's a very basic unit of technology for deploying apps. And so for most customers, how they deploy apps today, like I sort of described in my operations experience, it was the developer team reaches out to the ops team via a ticket queue and throws their tarball on some FTP site or email, whatever is really the best at what you're trying to solve, and that gets manually deployed by the operations team, which is usually a very painful process for the ops team to try and go figure out how this thing actually works. And so the goal is really to talk to the API-driven self-service environment, having developers communicate directly with an API where they can schedule jobs to communicate to, instead of communicating directly to an operations team, but Nomad would be the platform where they can schedule to directly. And then the operations team is just maintaining the platform and all the integrations for them. And the reason why we believe that's the way forward is because we want to empower developers to create self-service deployments. This is, instead of relying on the operations team to do it for them, we want them to give them access to it. We also want to make it scalable, so that way, the manual process of operations doing this just doesn't scale with the business. You want to have developers sort of owning a larger percentage of the process. Okay, so for most developers, though, there is this clear dividing line between what are the systems I interact with and what am I able to see. And so what we need to do to sort of grant that autonomy to our developer teams, we have to give them observability into what's going on the platform underneath. And so you'll see, as part of the HashiCorp sort of roadmaps, you'll see a greater emphasis on observability tooling to empower developers to be more self-sufficient with the platform. Okay, let's navigate what this transformation looks like, organization-wise and people-wise as well. Okay, so there's always sort of the big bang of change, which is CIO gets on stage. I think this I think famously the CIO for Capital One was on stage with Andy Jassy at AWS several years ago now, and he said we are all in with public cloud. And exactly 2 years later, I can tell you exactly how much it changed, which is about 0. And the reason why was because, yes, even though you have this mandate from on high to sort of change things, it also comes with this implicit mandate, just don't break anything, because the IT department gets paid for serviceability, reliability, stability, and a lot of those abilities that kind of factor in. And so it's important not to break anything. And that makes it really hard, right? Because if you're already at capacity or near capacity in terms of your work, say you're 90% busy, well, that means that you're allocating 4 hours every work week to investigate something new. And it takes a really, really long time to get anything meaningful done if you're doing that. And so what we found is that for most IT organizations undergoing this change, they need to allocate time to the folks looking at how do we change our processes. And so if you're thinking about it in terms of a tree, the ITIL organization, it's a sequoia. It's this giant tree with like this trunk that is like hundreds of layers deep. And, the center ring is sort of mainframe and UDB, and then, maybe oracles around that, and sort of spirals out from there. And so the DevOps organization is in large part dedicated to finding a new set of processes. And so these new processes define how people are consuming the infrastructure, and they are trying to make it so that the phrase we use in the States is that paved path is the easy path, meaning you want to make it as easy as possible through automation for people to get their work done. And then over time, if you have made it easier, what you start to see is that applications sort of drain away from the ITIL processes, and they move towards these new DevOps processes in the way of deployment, that this is easier. So most of these organizations, there's kind of a lot to dig into here that I unfortunately don't have time. However, most of the organizations that are successful moving towards DevOps, they brought sort of a different set of skills to the conversation, which we're going to talk through in a minute. They also have a set of KPIs associated with the time to value. That's also very important. I think also important is the things that they solve. Right? So making a list of here's all the 70 steps, right, that was in the other process. Here are the things where you moved it to one step. And if you want to, do your own thing, that's okay. But you have to solve these 70 steps, not necessarily the exact way we did it, but you have to solve them, right? You have to solve, like, how do we do artifacts, and how do we do security review, and how do we do application deployments? Like, those things all have to be solved. And you really have to start thinking about what are the easy ways to solve them, and what are the rules that you're going to enforce across the organization. So that's a pattern that we've seen that's very successful. Now, one case study we have is Goldman Sachs. Now, Goldman Sachs has some of the best technologists in the world. I think I'll be upfront about that. I think they would agree with me. The problem with Goldman Sachs was not their technology prowess. The challenge there was that their processes were sort of based and rooted in that, these ITIL processes. And what they found is that what needed to change was not their training, it was their approach to how they deployed infrastructure. And so a large part of Goldman Sachs' push into community and retail banking in the form of credit card, that is what Marcus does. Is it's the credit card holding company for Goldman Sachs. They needed to change how quickly you're able to deploy, because that was a product that was very sensitive to time to market. So they really had to think about what are the processes that we want in place, and how do we make things that they can move as quickly as possible. Okay, so here are some clear success patterns, which already, I alluded to a couple of these. And the first is having an executive sponsor. Now, if you're thinking about adopting a tool, well, a tool is usually something that's philosophy specific, and that can be, adopted on like almost a person by person basis. But if you're changing process, and if you're changing the skill sets of the rest of the people in the org for scale, you need to have an executive sponsor. It's critically important. Every project I've ever seen that didn't have an executive sponsor has failed. Every single one. It's a million for a million. The second thing that we've seen is having a clear alignment to a business group. So making sure that as you're solving problems, that it solves a very clear business problem. Now, some groups we've spoken to, they don't have this clear alignment. And so they build platforms that, they solve every problem, but because they don't solve them in a way the business can use them, they end up like building like sort of this, white castle in the sky that, it's kind of pointless. No one can really access it, and no one can, it doesn't provide anything useful. So having a clear alignment means that as you're building things, it's providing direct value. You're able to prove back to the business on the things you're doing work. And it's also able to demonstrate that, the problems that you're solving with the platform are relevant. The third point is really around staffing with modern practitioners. Now, there's plenty of folks in your company who have talent. So some folks are able to reskill. And, that's part of the staffing modern practitioners, is part of those reskilling folks that want to be reskilled. Now, some of the challenges that you have to have people that think a little differently, they have to start thinking about workflow. And if the folks who design your ITIL-based workflows are designing your DevOps-based workflows, well, it's almost a guarantee that you're going to end up with a DevOps workflow that looks very similar to your ITIL processes. So that is a clear pattern of success, is just having people who think differently about the problem. That doesn't necessarily mean that the people who developed the original problem was bad. That's the way we always did things. It's they have to really think about what is that time to value and how do we do things differently. So here are some conclusions. I think the first is that you have to think about digital transformation, which is a very overloaded term now, but it's really the best sort of definition we have around these technology transformations. That impacts every layer within a company. Systems, yes, for sure, but what are the processes you need on top of those? And most importantly, how does it impact the people, and what are the changing skill sets you need to worry about? And so you need to start thinking about investing in retraining, finding that coalition of the willing and augmenting that with people who are external to the company, but more accustomed to the way that public cloud does things. We call those cloud native people. And you also have to locate and identify who are the change resistant ITIL org in those staff. I think part of that is because, I mean, like VMware is not going to go away tomorrow. It's realistically not how it's going to happen. And you're always going to need a VMware team, at least for the foreseeable future. Sometimes those folks can find a place without having to change that much. And sometimes some of those folks are not going to find a place. And you have to be willing to sort of identify those people and find out their willingness to change. Change is very hard for everybody. Second thing, and I sort of reiterated this a few times, you have to think about ticket-based processes being the red flag. That should be the exception, not the norm. You have to think about designing for both self-service and workflows. Right? So workflows are the thing that people care about. Those are the things that make people effective. Those are the things that drive KPIs. The technology underneath is just a detail. How do you get work done is differentiated from what technology we're doing to get that done. We have a lot of customers. One example would be like the Bank of New York Mellon, where even though they use VMware on-premise, because they are sort of focused around the workflow and how people consume, they can deploy things just as quickly as they could within public cloud. And they do that because they have all sorts of regulatory constraints around them. So think about the workflow, the technology is a detail. You have to start replacing those ticket queues with something. You can't just tell people like, oh yeah, go figure it out on your own. Like that's not a viable option. So we have to think about what are the systems that replace those ticket queues and how do the APIs get consumed. We also have to start thinking about supporting heterogeneous environments. As I mentioned earlier, for customers we've spoken to that were all in with one cloud provider, they went all in and then they acquired another company that was all in with a different one. And all of a sudden, all the assumptions that they made at the beginning all changed. So definitely design your systems to support heterogeneity. Okay, and my last point here before I take some questions is that the VMware adoption, we sort of point to VMware a lot. It made a lot of difference in the technology industry. Most companies started their VMware migration in earnest, maybe between 2004 and 2005. Most of those adoptions were completed roughly in, let's say, 2016, 2017. It took at least 10 years for most companies, and that was a technology adoption. So anytime I've heard that an organization is going to change its people and its processes and its skills within like a year or 18 months, like it's not going to happen. It's not going to be successful. You have to accept it's going to take a longer period of time, especially people. People take a very long time to change. Now, the best way you can drive success with your projects is by aligning to groups that have really high business value. If you can do that, you can sort of get other people on the journey with you and show them demonstrably the value that you're delivering, how it's made life easier. And that's it. So I think that's it for the presentation. Thank you for coming, I guess, this afternoon. Let's look at the Q&A. Connor.
Let's go. Yeah, we've had a couple of questions coming through. So we'll start from the top. Are there any resources on how Console works with AWS?
Yes, actually, there's a few. There's a couple of articles that we posted on the HashiCorp resources page. So hashicorp.com/resources. That's one place to start. Those are typically either how-to guides or customer stories. A customer story would be somebody like Segment, for example, who's published on how they saved all kinds of money by using Console as their DNS. Instead of using load balancers for indirection, all of a sudden they could use DNS, where it would just return an active IP address of the service every time it was requested. And it allowed them to save all that money on the application load balancer transfer charges. So that's one. I'd say another resource would be to go to the HashiCorp Learn portal. So learn.hashicorp.com. What that is it's a website that we've created to walk people through in tutorial format how the different technologies works. And so console has its own section. It'll walk you through how to start the service, how it works, what are some basics, as well as how does it integrate with AWS specific features.
Okay, fantastic. Now, bear with me. This is a long one, but it's a really good question. So, what are the first steps that you discover yields the best initial return on investment? And once return on investment diminishes, how do you perpetuate the positive culture change beyond the initial and arguably revolutionary changes?
Right. I mean, great question. The first steps we found is that you need to have some sort of value delivered. And so I said not to focus on the tools initially. What typically happens is you have some goal that's put forward by, typically a security team. So most customers who start with HashiCorp start with either, a Terraform or a Vault. And it's either, in the form of two things. So one is people find that starting with their own operations team, and even if the process up front doesn't change, it's still a ticket process, they can start using these templated infrastructure as code versions that allow them to very quickly and easily replicate infrastructure that's been created. So that's one, sort of starting off with infrastructure as code and seeing it at work in the environment. And then shifting towards more being API centric and providing the API externally to the rest of the organization. So that's one. The second is around the security portion. I think for most customers, security is always going to be just a challenge they're going to have to both endure and press forward on. And so to solve some of the security problems related to code hygiene, I think everyone points to secrets in source code as being a huge problem. In terms of the risk associated with it, if you were leaving credentials in source code, that could give any sort of attacker on network access to all your database, information. And so what we see is sort of the second type of effort that's successful is the first step is to improve security hygiene and to show that there is a demonstrable business outcome in terms of risk, or in terms of risk reduction, probably a better way to put it. And I think those two things are usually something that, like, once people see it at work and they see that their lives get easier through a tool like Vault, you can make API access a reality very quickly, using the Learn portal, and just makes it so that people are able to do work very quickly. And it's really about that. It's really about how can you show people that their lives get easier by using a new process and a new approach. And so I would definitely recommend looking at what are those pain points in the organization. Typically, they're around how do we manage secrets and maintain code hygiene? How do we make things easily repeatable? I pointed out some of those stats around automation for most operators in the Nordics. So it's really around having things be easy, and then you can sort of walk people forward into the different types of problems that you can help them solve. And it really is around like that. What I said, I mentioned a coalition of the willing. There is a retail organization in North America that what they did to build that coalition of the willing was they had like a token, and now would be kind of irrelevant because like all these people put the token on the top of their desk, but it was something where as you were walking by the office, you could clearly identify who was part of their coalition and not, just by the fact that they had a token on their desk. So it was something that like they built their own culture on their team around agile delivery, and just over time they were able to demonstrate a lot of business value. So they were very successful. Hope that answers your question.
All right. Yeah, great job, Brent. On to the next one. How do you handle incident management in a DevOps approach? Is it just having the full stack team handling incidents, or is it relying on infrastructure as code rollback options in pipeline deployments?
Yeah, also another great question. I think, that's when we talk about observability tooling, usually you push observability tooling to an SRE organization, and they're the ones responsible for just like the way that you'd handle problems in the infrastructure. They need that observability to be able to effectively troubleshoot the platform. Now, sometimes those that SRE organization, you may have people that worked within your that provisioning team that then moved out of the provisioning team back into the line of business. That's a very common approach that we see, that they do, like it's almost like an internship with the provisioning team. They move back out and they sort of understand how things got built, and they can, I think, more easily troubleshoot it. But the observability tooling, with things like Honeycomb, things like that, it allows them to sort of look at what their application is doing and try and troubleshoot if there's a problem with their application, or is it a problem with the platform. So I'd say that's probably number one. I'm sorry, Connor, you here, let me pull the question back up. The terms of in terms of like having infrastructure as code rollback options, most customers will sort of roll forward with infrastructure as code, not necessarily roll back. And so you'd want to find where the problem was, roll forward with the new version. Within Terraform, we allow you to version modules. And so you can say, we can sort of prevent the problem from happening using tools like TerraTest. We can version the module so that way we know what exactly got deployed, where the problem was, and then we can roll forward with the new version. And I guess like in most circumstances, you wouldn't necessarily want to roll back infrastructure as code. You'd roll forward with it, but you might roll back on a container version. So slightly different, right? So if you're using container-based deployments, you would use just a previous revision to it, or you can do the same thing. You apply your patch and just roll forward, right? So there's a couple different approaches there, but I would generally say, instead, like rolling back sounds good, but it's really about like finding the problem, remediating it, and then rolling forward with the new release.
All right, and then just the last question here is there a place where I can find reference architectures?
There is. We just updated. So the Learn portal has several reference architectures for both Vault and Console. Excuse me, for some of the the different types of deployments on different providers, which will be different on VMware than it will on AWS by nature of AWS's availability zones, and things like VMware do not. So you can find some of those reference architectures linked on the Learn portal. I don't know offhand if it includes the Terraform Enterprise reference architecture. I believe that's something where if you have Terraform Enterprise, you have access to our enterprise architecture team. They're the ones who maintain the reference architectures to date. So I'd say generally that we try and publish them publicly. There may be a couple related to Terraform Enterprise that are just, they're designed for for customer use by modules that we maintain internally.
Cool. All right. Well, with that, we conclude today's webinar. Thanks a lot, Brent, for this presentation and for everyone joining us today. As I mentioned at the beginning, this webinar was recorded and we'll make that available via email later this week. As Brent mentioned, if you liked what you heard today and you want to start exploring any of our products, then I encourage you to check out our Learn site. And you can find that at learn.hashicorp.com. And I'll put a link to that in the email as well.
Very good.
Last but not least, I also just want to mention HashiConf Digital, which we have coming up on the 12th to the 15th of October. Now that will be a great opportunity to hear from our founders, who will be talking about some really exciting product announcements that you won't want to miss. And there'll also be a selection of other keynotes, technical deep dive sessions and workshops there as well. A majority of those will be recorded in case you're unable to attend live, and you can register at hashiconf.com/digital. So with that, I hope you enjoyed today's session, and thanks so much for joining us. Thanks, Brent. Goodbye.
Thank you, Connor. Take care, everybody.